In this video, I'm going to show how to solve the ice skater problem that I assigned for my AP Physics students. There are a number of ways to do this problem. You don't have to do it the way I'm going to do it, but this is the way I'll do it. We're told that we have an ice skater who has an initial velocity. Let's have her like this. This is the ice skater. And she has an initial velocity of 10 meters per second. And because of friction, there's a frictional force acting on her that is slowing her down. So I'll draw a frictional force pushing back this way. And it causes her to come to a stop after a distance, d, of, it says, 100 meters. Of course, if there was no frictional force, she would just continue forward at the same rate indefinitely, and she would not come to a stop. But because there's a frictional force, she will. The goal of the problem is to figure out what the coefficient of friction is. So let's think about it this way. Let's make a plot of her velocity as a function of time. She starts out with some initial velocity, v0, and if she's decelerating, at some point she will come to a stop at some time. We'll call that t star. That's the time it takes for her to come to a stop. And during that time, she will travel some distance. Well, what's the distance traveled? It's just the area underneath this velocity versus time plot. Okay, so we can begin by finding out how much time it takes for her to come to a stop in order for the distance for her to go, again, which is represented by the area, to be 100 meters. Well, that distance is going to be equal to, we can use a mean speed theorem if we want. We can say it's just going to be the same distance as if she was moving at the mean velocity or the average velocity for the same amount of time. So we could find the area there, and it's just 1/2 of her initial velocity times the time during which she is moving. And so we can use that to find out what the amount of time it takes to come to a stop. We'll call that t star, and it would be 200 divided by her initial velocity, that's 200 meters, divided by 10 meters per second. And so how long is it going to take for her to come to a stop? It is going to be 20 seconds. Okay, once we have that, then we can figure out what her deceleration must have been. The acceleration, or in this case a deceleration, she lost 10 meters per second of speed, and it took 20 seconds. So it's 1/2 of a meter per second squared is her acceleration. If you know her acceleration, then we can probably find the coefficient of friction. Let's think about this for a moment. The coefficient of friction relates the frictional force to the normal force that's pushing up on her from the ice, and the normal force pushing up on her from the ice has to be equal to her weight, so mg, and that's equal to the frictional force that's acting on her. And what's that frictional force? Well, that causes her to decelerate. So now I'm going to use Newton's second law. The force acting on her, which we just said is mu times m times g, that's the frictional force, that is equal to her mass times her deceleration. The mass goes away, and so we can find the coefficient of friction as her deceleration divided by g, the acceleration of gravity, and we just found out that to be 1/2 of a meter per second squared, and we know g is about 10 meters per second squared, so 1/2 over 10 is 1/20 is the coefficient of friction, which is about equal to what? 0.05. And so there we have it. We have found the coefficient of friction that will bring her to a halt after coasting for 20 seconds. From an initial velocity of 10 meters per second, she comes to a stop in 100 meters.